This is Chapter 4, Worksheet question number 20, Population Growth or Decay. All right, Gillette, Wyoming had a population of 20,477 in the year 2000 and a population of 29,144 in the year 2010. Using the law of exponential growth, which is this formula A equals A sub 0 e to the kt, what will the population of Gillette be in 2025? Round to the nearest year. So we have two things happening here. We need to find K, and then we need to answer the question for 2025. Okay, so we're going to say that T equals 0 at the year 2000, which means at the year 2010, time equals 10. And therefore, for our final problem, T will equal 25 at the year 2025. So let's start by creating an equation and finding K. So the initial amount at time equals 0 is 20,477. So that's at time equals 0. That's what A sub 0 means, right? Then it has a population 10 years later of 29,144. So that is our amount as a function of t years later. So in this case, it's 10 years later, so it's 10. But we also have to have our k value to find that rate that makes this true. So our first job here is to find k. And in order to find k, we're going to need to use a logarithm. But we don't want to use a logarithm until we have our exponential isolated. So to do that, we're going to divide both sides by the coefficient of our exponential, which is 2477. So we're going to start by dividing both sides by 2477. And while this is a really ugly fraction over here, it's accomplished what we needed to, and we have, undo, it always does more than I think it will. So it's accomplished what we needed to, and we now have our exponential by itself. So now if we take the logarithm of each side, that coefficient's not going to be in the way. So next thing though is that because this is e, base e already, the best logarithm to use for each side would be a natural log. So we're going to use a natural log of 29,144 divided by 2477, and that will equal the natural log of e to the 10k. So then we go ahead and use our little logarithmic properties here, move our power to the front as a coefficient, and then also remember that natural log e, since it's base e, just equals 1, and 10 times k times 1 is just 10k. So it's like we don't even need to worry about that, like that's gone, right? So overall, we've now found k by taking this natural log of all this stuff and dividing by that stuff. Of course, I know these are just populations. And then overall dividing that by the 10 years that have passed in the time that that number changed. Okay, so it's going to give us an approximate value for k. Use my calculator here and figure that out. So the natural log, use a parenthesis, 29,144 divided by 20477, close the parenthesis, divide by the 10, and we get 0.035294675. I'm just going to write them all down because the more I have, the more accurate my answer will be. Okay, so there's k. I did the first part. Now I want to solve the problem. So the problem is, what will the population be in 2025? So we're trying to find the amount of population in 2025 with an initial population of 2477 in the year 2000, and now it's the year 2025, so we're going to do 25 years have passed, and we have our constant of growth here, this whole thing I just calculated with as many decimal places as I can get in there, and that that gives me an answer of and then e to the 25 times the answer I just got for k. So I got 49,484.98012. So I'm going to just round that to the whole number of people, 49,485. Now the answer key that we are using this year says the answer is 49,492. And after a little bit of experimentation, I figured out that I got that answer when I rounded my k value to 4 decimal places. But it's always better to use more decimal places and get as accurate as an answer as possible. So I'm going to say that the correct answer for this question is 49,485.